All right, so we're going to go over JavaScript classes, and you already know how these work. You've just seen them in another way. So JavaScript classes are for our blueprints for generating JS objects. What other JavaScript thing did we learn that does this? Constructors. So before ES6, we had the constructor function and the prototype syntax. You know, we have function car as a make and a model. And we can apply the blueprint to show how the object should be created when we instantiate it by using the this keyword. Then if we wanted to describe something the car does, we would add it to the car's prototype. So like honk. And so that's what we've been working with, and this syntax is still fully supported and you'll still see it. But ES6 deemed to improve upon this in a couple ways. And the way it did that was it pulled in JavaScript classes. Has anyone ever in here ever coded in Java?
I did for another boot camp.
Okay, so if you've seen Java, you've seen classes. That's every line of code you write in Java is in a class. JavaScript syntax for classes is very, very similar, even though the underlying mechanism is slightly different. It does bring some familiarity to JavaScript to make it look like more like an object-oriented language. But really, it's just doing this with a cleaner syntax. So let's look at
an object-oriented language.
Yes, that's a discussion. So if you want to learn about object-oriented languages, the first thing you should read is about the 4 pillars of object-oriented programming. There's 4 principles in object-oriented programming that encapsulate what it is to be an object-oriented language.
What's the book called again?
It's not a book, but if you Google search, let's see, 4 pillars of OOP, object-oriented programming. It is abstraction, encapsulation, inheritance, and polymorphism. So you read about this, and these are the four principles that, when tied together, create this paradigm of programming where you orient things in almost a hierarchy. There we go, where you declare objects that can do things, but we're going to see in a moment the syntax that JS classes introduced that show how we can create this hierarchy with our prototypes and with our classes. And that's really what object-oriented languages do. It's a way of organizing your program, and most popular object-oriented languages are Java and C#, C++. And JavaScript can simulate it. So if you ever read on Medium, that's usually a really good place to learn. Whenever I see a Medium article, I usually jump to that first, as they give you a pretty good, the writers on Medium are pretty solid. All right. So classes, we're going to make a class called vehicle. Go back to that example. Just like we did with car, when you're declaring a JavaScript class, you have to use the keyword class and then the name of the class. So I'm going to make a class called vehicle, and it just gets opening and closing curly brackets after its declaration.
Capital letter required.
Capital letter required, just like a constructor function. This is when we instantiate this, we'll still say new vehicle, just like we do with constructor functions, and it will return the object. But everything, the constructor and the prototype are all included in the class, which is nice. Now we're not having to type them in separate pieces. They're all encapsulated within these 2 brackets, which is one of the principles of OOP, encapsulation, meaning that what it means to be a vehicle should be everything that a vehicle is, and what it does should be encapsulated within its blueprint. It defines how this object works in my program. So we still split it into two pieces, but it's all part of the class. The first part is the constructor. And now we actually use a keyword called constructor that gets parentheses and curly brackets. This is in place of the constructor function. So this right here is going to be doing what this portion of our constructor function did. So the constructor needs to know what properties will this object have. The constructor defines what it is to be a vehicle. So all vehicles in our program will have a make and a model. And for the sake of using methods later, we'll also say honk sound. And we'll apply those properties to the object the same way we do with constructor functions. So this dot make equals make, dot model equals model, and honk sound. Not too different, right? I mean, there's two new keywords. There's class and there's constructor, but we've set up this basically at this point. Any questions up to this point? Cool. All right, so this section again is what it is to be a car or be a vehicle. After the constructor, but before the class closes, this is where we declare all the prototypal methods. So we don't have to say vehicle.prototype.honk equals a function. We can just write the functions inside of a blueprint here, and it will automatically be added to the prototype, not the constructor. And the syntax for this, you don't use the function keyword, you don't do anything like that. You just write the name of the function, give it parentheses and curly brackets. And now I'm declaring a prototypal method for my vehicle class. And it will console.log honk. Maybe we're expanding onto this. There's other doing words, so we can just hit enter and write another method in here. And it does something, not much right now, but now we can instantiate vehicles that get this constructor. We can pass them the three properties to have them applied, and they'll automatically have these methods in the prototype, the blueprint. So let's instantiate one. We'll say const Jeep is a new vehicle. Jeep, Cherokee, something that we can tell it's different. Okay, so there is my vehicle, and it has all the properties. If I console log Jeep, when I console log Jeep, what will I see in that object? What will that object look like? How many properties will we be able to see? Any other votes for 3, 2, 1, 4?
Won't it also show the honk and drive?
Will it? That's what I'm getting at. Will it show the methods?
No, because you're not.
All I see is its constructor properties. The blueprint's in the background. Or sorry, the prototype methods are in the background. It's something that all cars can use, but it's not a property of each car object. We don't want that. We only want one version of the function to exist, but each vehicle can use it because it's in its prototype. So we only see the constructor properties, the things that define what this vehicle is, but what vehicles do, all of them share that, and so we won't see them as a property of the object. Just like constructor functions. If we console logged after instantiating car, we wouldn't see honk, we would just see these two properties.
I think this would have been good to use for RPG.
Yeah, you gotta get used to the constructor function syntax first before moving to this, but yeah. It does the same thing. It's just a little easier to look at once you get used to it. And we, every time there's certain components in React that are class components, and we'll be using the syntax all the time within like a week of learning React. So this is gonna become a very normal thing. But there's more to it, of course.
So how would you get honk and drive to show up on Jeep?
I can make them properties of the constructor, but that means every car that gets created has their own version of the function, even though the function does the same thing. So you wouldn't want to do this, but this would make it so now I'm going to remove honk from here. Need to close this function. And now when I console log the Jeep, I will see honk as a property of it, but I don't want that. I only want one version of this to exist. So if I really need to see this and it's added to the prototype, not the constructor, I can still see it as long as I have an HTML file and I look in the DevTools, because those give you a better look at your data. Let me just link this really quick and we can check it out. Okay, so now here's a vehicle in the DevTools. If I go into here, we still only see its properties, but we also have access to see its prototype. And it's when we go into here that we can see the methods. We can see that its constructor was built as a vehicle class. And funny enough, each prototype has its own prototype because there are objects, and there's all the object methods. It's a never-ending maze you can find yourself in. But that's how you'd see any piece of data's prototype. The easiest place to see it is in DevTools. To prove that it does exist, it's just not a property of each object. It's existing in the blueprint. Cool. Well, let's say we're building this program and we said vehicle first, but then as our program gets larger, maybe maybe this is a website or a program for used cars, and we need to be able to differentiate different types of cars that have different properties. All cars will have a make, model, and honk sound, but some of them will have properties that other ones don't. And so we wouldn't include it in the vehicle. This is like the top level class that represents all vehicles, because not all vehicles will fit the shape of maybe having, going back to this example, has sidecar. Not all vehicles will have a sidecar. So we can make another class that uses all of this and also adds on to it. And this is something that classes made very easily. It's a way of extending a class. So we're going to make a class motorcycle. And does a motorcycle do all of this stuff? So would I do this? What rule did I just break? Don't repeat yourself. And I definitely just did. If this has the same properties as this, we can tell my motorcycle class to inherit all these properties and then also add to it the things that are unique to a motorcycle, making kind of a subclass. So instead of declaring all of this again, I'm going to slim this down to the base syntax. Okay, so this is what we absolutely need to start off with. We still need to tell the constructor what properties it's going to receive. But we can tell the motorcycle class with another keyword to extend another class. And what this does is it allows anything created as a motorcycle. Let's say I create a motorcycle in this program, and I say motorcycle.honk. It'll notice that the motorcycle blueprint doesn't have a honk method, so then it can go look at the vehicle blueprint, and if it has a honk method, it can use that one. Still making it so that method only exists once in memory, and my subclass objects can still use it. Well, there's one other property we're going to give motorcycle, and that is has sidecar. And so I go in here and I start applying my constructor. But again, what rule am I breaking when I do this? I'm repeating myself again. So whenever you find yourself repeating this stuff that you have in another part of your program, there's got to be a way to not have to do this. All I need to really apply is this dot has sidecar, because that is unique to this class. But I do need to teach the constructor how to apply these three other pieces of data that I'm passing in. So how does one do that? Super. Both an exclamation and the right answer. Super. So what I can do in a subclass is I can say, look at your super. It's a method I call in the constructor. And I can tell the super, what the super does is it looks at the class, your class is extending, and you tell it what things to look for. Say, go look for the make, the model, and the honk sound. What super will do is we'll go look at the super class, the parent class, with the 3 items that we're instructing it with, make, model, honk, sound, and basically just gets this information. It understands how to apply those properties to the object. So this line is just replacing these 3 lines, so I don't have to repeat myself. If I'm extending a class that already has these instructions, I don't need to write it again. I just need to go, hey, look at your super class, look at the one you're extending to figure out how to apply those pieces of data. And then the one that's unique to you, this is how you apply it. Yeah.
You can also exclude one of those variables in the super if you didn't want like the model.
That's the thing. So we have to think of hierarchy. That's why I made this one very general up top, vehicle. These are the 3 properties that I, in my program, said every vehicle, regardless of what type, are going to at least have these 3. So I can keep extending this and not have to repeat myself when I make smaller and smaller classes. So you have to think about hierarchy. What's something that all of them are going to have, and then get more and more specific with the classes that will extend that main class. Caitlin?
So if you're wanting to like make another layer extend out to motorcycle, would you just do a class, whatever you call that, extend motorcycle?
Yeah.
And just have that point at the motorcycle and not have to worry about having it point to the vehicle since it points to the motorcycle?
Yep, if I write another class that extends off of motorcycle, I could. And let's say that is like a class tricycle. It makes no sense, but it will have a make, a model, and a honk sound maybe. So, you know, and we could say extends motorcycle. The funny thing is, if I do all this the same, my tricycles can call the honk method from vehicle, because tricycle extends motorcycle, motorcycle extends vehicle, and vehicle has a honk method. Any subclass, even if it's multiple layers down, still have access to that blueprint.
And you would do super the same, you would just add that sidecar to it?
Yep, it's a super, make, model, honk, sound, and I could leave out has sidecar. Like, hey, you're going to receive a make, a model, and a honk sound, and maybe a age limit, because yeah. So your super would say go look up for make, model, and honk sound, and this dot age limit equals age limit. I'm leaving out has sidecar because my tricycles won't. So when I instruct super to go look at its parent class, it's going to just look at these 3 properties to know how to apply it, which looks at this class, which says, oh, you need to go look at those 3 properties up above to know how to apply it. It'll look up and up and up until it finds the instructions. If it finds nothing, it breaks your program.
Cool.
Okay, so another part of this, let's instantiate a motorcycle. Harley Davidson, LARP, and True. And we're going to see if this works. We're going to say Harley.honk and see if this class is able to look at this class's blueprint. All right, it did. Now, when I write the honk sound, I want it to say the Harley's honk, this LARP word that I put here, instead of honk. So what would I need to write here in this honk method for it to actually do the object's property? It's a very common word in classes and constructors. It's how we refer to the object itself. This, console log this dot honk sound. And this is great since all vehicles, all motorcycles will have a honk sound. This method will work on any of those types of objects and console log that object's property, regardless of whether it's a vehicle or motorcycle. This is going to work the same. So now when I say Harley.honk, I get its honk sound. Pretty cool, right?
Yes.
If you like this type of programming, learn Java. This is Java based. I mean, this isn't Java, but every line of code you write in Java is in a class. You don't write code outside of it. So that's pure object oriented. You have objects interacting with other objects that create your program. It's pretty cool.
I like how JavaScript can do different things.
Yeah, it's like I can do this if I want, but I can also do functional, or I can do really a mix of anything if I really want to. When we write React, we do a mix of object-oriented and functional and prototypal, so it's nice to kind of have that option. But more and more JavaScript libraries and code are getting closer to the functional programming, which we will definitely get into as well. Okay, so that's classes. Oop. Give you an example of how I've used a class before. Dodgem.surge.sh, I think. This is a little game I made after I left the course, just for practice. And it's, dodge the red dot with your blue dot. Every time you hit it, a life goes down, you can see at the top, but a green one will appear and you can get lives back. Your dot gets bigger or smaller depending on how much life you have. As the score gets higher, there's more and more, and eventually you lose.
Publish this. I bet people want it.
Yeah,
People like this guy here.
it's fun. Yeah.
There's a game that has a huge following where you just eat other people's
The worm one?
Is it that one where you just get bigger and bigger and bigger?
Right, so how many classes do we see here possibly? 3. Yeah, I use 3 classes. What are the 3 classes you see?
Blue dot, red dot, green dot.
Player, enemy, life. Yeah, so blue dot's the player, red dot's the enemy, green dot's the life. I declared the constructor, like the player, the size, how much life it has. When I move the mouse, how should it react? That was one of the methods. The red dots, depending on where they start in the screen, moving left, moving right, all those things, those action words were properties of it. When they collide, that was a property of the enemy object, checking to see if it's hitting the same pixel space as the player. And then the green one that just generates randomly, gives you health, makes you big, and so on. You can always look at people's code too. If they're not using a package, you can go into sources and click on their JavaScript file, and there's the code for it. I did use Canvas, but there's my ball constructor. It has an X and a Y on the page that starts on, and it has, that looks like that's all it is, because it just follows my mouse. The enemies, though, has positioning, velocity, and direction, and has properties like move that tells it how to move. So every one of these red objects are just an instantiated class. So they are very applicable.
Put that code on Slack so I can study.
You can go to be aware, I haven't updated this since I left the course. I've been very bad at that. Don't follow my example. This is my website for after the course. Here's all the little things I made right after, and it's this one right here.
Were you trying to get into games?
I was just trying to keep myself busy. Yeah, I like making games, so I kept doing that for a bit.
And they could get a lot more attraction if you said it was fully free.
Bully free?
Fully free, yeah, but your game has no bullies in it.
Oh yeah, no.
Dodgeball usually does.
Yeah, there's no chat rooms you can braid each other in, so yeah, no fun. Cool, those are classes.